Hi, welcome to my kitchen. In this video I will explain a work in progress. This is the first chapter of a series of videos that I will do. This is a documentation of my work. So this is just the beginning of this work. My intention is to create a modulator which is going to control a hardware synthesizer for making generative music. So I have a mathematical function which is creating this image in here, and I am transforming this image into a signal, an MSP signal, and then this signal I am given that for controlling the cutoff frequency of a filter. So let's review this. Well, this is a big picture, okay. So then I have a synthesizer in here. And okay, and this is controlling the cutoff frequency. So let's explain this in detail. So I have the generator of this image in here, which later is going to be transformed into a signal, is this object called jit.bfg. So this object can read math functions. So for example, if the attribute basis is going to give me the name of the function, this is noise.simplex, then I can change, for example, to noise.warnai, and it looks so different. Then I can choose to fractal mono, and this other attribute scales allows me to go, it's kind of a zoom, I can zoom in, zoom out, and I am just generating values in this function. And like, for example, this very different choices like noise cell, for example. And okay, so the idea is to listen this image, right? This is a visual modulator. So this object jit.bfg contains only one plane, means that it is actually putting these values into a matrix. A matrix is a kind of table, like an Excel table, and it has only one value for each cell. This is what it means, this argument. And later, these values inside the matrix are floating 32, these numbers with floating points. The number of cells in this matrix is determined in here. These dimensions are 256 by 256, the dimensions. And then I specified 5 here for the scale. It's the same attribute here that I am changing in here. And the type of noise that I am using. So you can see that later I am giving that, well, later, since this number is small, I am normalizing it. I put it in a range between 0 and 1. Then I am making a map in here. This is kind of like the scale object, but it is for matrices. So this is the jit.map object, and here I am mapping from the range from 0 to 1 to the range from -1 to 1, so I can see my signal in the entire scope in here. And then this is the other key object in here, which is the jit.release, which is transforming this matrix into a signal. And I am using mode 1, which means that I am creating an interpolation between the values. If I don't do that, and I do just mode 0, the signal is quite is flicking, is not as stable, and it's not really reflecting what this is in the image. So mode 1 is gonna make it right. The latency, okay, the smaller the latency is, for example 0.1, the image is gonna be more, it's gonna resemble more this image, right? Because when the latency is large, so you don't really can appreciate the same result. So I am putting that as small as my CPU can allow me to do it. Then I am well, I could connect just the release to a something else. My intention is to control, as I said before, the cutoff frequency of a filter. Then I want to avoid really fast changes of frequency. This is what I am using this one pole filter in here. So look what happens when I change here the value to 5. I am smoothing the signal. Actually, I'm letting out all the fast frequency changes. The largest is this number. More high frequencies I will find in my signal. So let's look, this is really big. Okay, so this will be one of the parameters I will be able to control when I will be using this instrument that I am building in here. Then I am giving this one pole thing to a scale. So I am transforming this, I'm scaling this range from -1 to 1 to the human being hearing range, which is from 20 Hertz to 20,000 Hertz. Then transforming this signal into number, so it can pass us a message. And then finally, I'm giving that value to a to the cutoff frequency of filter. The filter is inside this poly object in here. Whoop. There you go. So this is the filter that is affecting all the notes which are being played in the synthesizer. This is a 16 voice synthesizer with a still function available and an envelope. And okay, so my intention is that I will now, well, I just made this synthesizer here in order to test the first results, but I really don't like this sound. Why? Because I like hardware synthesizers more than a well, it's just a choice, so I will give that number to the cutoff. Sorry, yeah, I will use I will control the filter wheel in my Prophet Rev 2. So this is why, in order to send this information here, so now I need to scale this into the MIDI range. Actually, also an option is that I probably could, yeah, I could scale it directly from here and not, because this is kind of redundant. So, but it's gonna be a signal again. And then, well, anyways, I will optimize that later. Yeah, I wanted just to give that directly here. We'll do it later. I will think what is the best method. And then, in order to know what is the controller in my synthesizer, the Rev 2, I will use this control in object. So when I will move the knob, which is going to be the filter, the controller number is going to show up in here, and this is the MIDI value. So then I will give that controller number, and this is the MIDI channel, and here I will give no you, but you. I will give that value to the controller, and I will let you listen to the results, guys, on the next chapter. So also this signal could be useful in order to modulate other things, of course. I am thinking now this is the first implementation about transforming this into a signal, and I will be testing that, mapping that to other hardware synthesizer controllers, and let's see how it works. It would be really nice to do it with the modular synthesizer, so it can pass directly not from MIDI but to voltage. So I don't have yet a voltage interface. I wanna use the Z Sleepers S9, I think is the name. So looking forward to being able to use to transform that directly to voltage. So one interesting thing that I want to talk is to talk about when you change the dimension numbers. For example, WIP. Actually, the results in release and release change. So these are the settings that work the best for me. The thing is pretty sensitive, even when I am just clicking over the patch in here. When I was listening to the results, connecting release directly to the EasyDuck. Look, let's do this. Oh, watch your ears, because this is probably gonna be unpleasant. So look. And now scope is showing anything. Oops. It is bulky. There you go. So look, I will change the to a gradient. Now I'm just using release. The sound output is already interesting, but I'm not convinced about timbre, because it sounds so. It's not the kind of sounds that is not fancy. Well, not the kind of sounds that I like. Then this is why I want to give that to hardware synthesizer and do more interesting things concerning to timbre. But it's already a very interesting and beautiful signal here. It sounds so natural, since the functions are, well, some of them modulations of nature. Well, see you next chapter, and you will see how that work is going. So sharing with you my kitchen. This was chapter 1. Let me know if you want me to test something specifically, and I might do it. I don't say I will because I don't know what are you going to ask or if I will have enough time. Alright, so thank you guys for watching, and create some beautiful things out there. Bye bye.